This video demonstrates our solution to the problem of securely transferring files over an insecure medium to multiple other parties and storing it persistently on the cloud without the risk of any other third parties accessing the contents of those files. The solution involves three major components: a central file server, a notification server, and associated client user interfaces.
We begin by initializing the database of all users on the server. The log messages indicate that the database is now initialized, and so the non-existent user Alice would fail to log in. We thus register Alice on the server. We also verify that the registration was successful. Likewise, both Bob and Charlie are registered. For the purposes of this demo, let's consider that Alice wants to share a sample file sample.txt with Bob. The sample.txt is populated with sample content. Since the database has just been initialized, no one currently owns the file. Thus, we verify that nobody owns the file by checking if we get the permission to resource denied error. So we simply set it to be owned by both Alice and Bob. Let's now verify that they have been successfully set as owners of the file. Now that the server is aware of the file and its owners, we now demo how notifications are received on the notification server. So let's go ahead and fire up the notification server and have Alice and Bob log into their timeline clients. We can now simulate an action on a file and the associated notification to its owners. In this case, a notification to the owners of the sample file, Alice and Bob. And as you can see, all owners were notified. Now that we don't need Bob anymore, let's have him disconnect abruptly. Note how the server timed out his connection using our own heartbeat protocol. Our notification system also supports queuing of notifications of users who are offline. To demonstrate this, let's queue a message for Charlie and have Charlie log in after the fact. On logging in, he immediately receives all such queued messages. This conclusively demonstrates our notification system.
Finally, the central file server acts as a shared storage resource to a set of registered users. Let's demonstrate this by starting up the server and the corresponding clients for Alice and Bob. As we know that the medium is insecure in nature, we perform a mandatory key exchange protocol between the client and the server. This paves way for a secure tunnel to perform further user authentication. The log messages indicate that there is a key exchange protocol that takes place between the server and the client. Furthermore, for added security, we have created a custom terminal emulator that supports only specific whitelisted commands. Any other commands throw exceptions, preventing any unauthorized actions from the client side. Some of these whitelisted commands allow for making a directory, changing directories, listing the files in their current directory, and removing files as well. We've also integrated two dedicated commands for secure client-server interactions. These interactions are implemented using the send and receive commands. But before that, note that each user is granted access to his own jail, which only he or she owns and accesses. In addition, he can also access files that are shared by other users. In our case, both Alice and Bob share the same file sample.txt. Note that all files sent to the server by the users undergo client-side encryption, ensuring that the server never sees the original files. Conveniently, in our case, Alice needs to send a file to Bob, for which she will use the send command. Let's investigate the file that was received on the server. As expected, we are unable to make sense of the ciphertext on the server's file system. Now, since Bob needs to receive the encrypted text from the server onto his local file system, we'll simulate his file system in the form of a subdirectory. He'll use the receive command. As you can see, the file has appeared on Bob's file system. This demo will work even if they are on remote machines that do not share the same file system or IP address. We also proposed a multi-party key exchange protocol whereby the different registered clients privately receive a key to decrypt files which are shared by the owner of that file. This exchange happens through the server and is immune to any passive man-in-the-middle attacks. This also means that any party, malicious or otherwise, despite having access to the network traffic through the server, would be incapable of deciphering the contents of the files.